Good morning, Tamina Khan is here in TKMaths is 1. In today's video, I'll explain to you the concept of normal approximation for binomial distribution, which is a part of the syllabus of A-level mathematics S1 paper. And it is paper 6 till 2019. After 2020 onward, it is called paper 5. I have picked up a question from June 19, variant 6.1, question 5, to explain the concept. So before we begin, you can see on the top my website address and my blog address. And do visit it. You will find it very useful. You will find many free videos over here, which will help you to learn building the concepts. So let's begin the question. So before beginning the question, I just want you to recall a few things which we will apply in this question. We know that normal distribution parameters are mu and variance, and it is written in this form, right? Whenever you write a question or solve a question, you always explain the parameters first. We know that in normal distribution, the shape of the curve is bell shape like this. It is asymmetrical about mean, right? The exact line from here from the center is mean. And the whole area under the curve is 1, right? And when it is written as phi z, which means probability of z less than z or less than equals to z. So it is written like this. This means same thing. Why it is not written equals to? Because we are talking about area left hand side of the curve. There is no area right under the line. Okay. So just remember phi z mean probability of z less than z. Second thing is you should know how to read the table, very important thing, normal standardized table or Z table. We know that there are 3 portions. The table we get in the exam have only positive Z value. So if we have negative Z value, we use symmetrical concept. I'll teach you. So all these are probability here, and on the top here and here, these are probability and these are Z values. In first decimal place, second decimal place, and here it is third decimal place. So let's see if it is written phi 1.798. It means probability of Z less than 1.798, right? So this is your Z value and you have to calculate probability. So first decimal is 7, second decimal is 9, third decimal is 8. So let's go to 1.7 first here. You can see I have marked with blue line here. So this is 1.7. Now 9 is my second decimal place, which is here. So if you come horizontally all the way from here till 9, it is 0.9633, right? But the third decimal place here is saying 8. So in the same line, if you go straight till you have 8 on the third decimal place here, the number is 7. So 0.9633 and 7 you will add up. Now remember, you will not just put in the calculator 0.9633 plus 7, because 7th is on the last, under the last digit of the probability. So you got your probability. So I can say the answer of this is 0.9640, right? Let's see here another example. If it is written phi z is equals to 0.9468, now what does it mean? It means now you have to find the value of z for which the left hand side probability is 94.68%. Okay, 0.9468. So now if you see here in the table, do I have 0.9468? I have already marked here to make it quick. I don't. It is 0.9463 and 74. If I read it as 6374, which is not the right way, but just to make it easy. So last 2 digits are 6374. And what are my last 2 digits? 68. So whenever you have such a case, you always take the probability less than this, 1 less than this, right? Just before it. So just before it is 0.9463. Now, if you see the difference between them, okay, forget about the first and second decimal place. Just look at the last 2 digits, 63 and 68. So what is the difference? right? So you will notice the difference is 5 because 68 minus 63 is 5. So you will go straight all the way here and look at 5 here. Okay. So now let's read. So 0.9463 is 1.6 first decimal place. Second decimal place is 1. So 1.61 and the difference was 5. On the top also it is 5. So third decimal place is 5. So it is 1.615. So this is how we read the table. So very important you understand how to read the table. So let's just start the question. What is this question saying? In a country, the probability that a child owns a bicycle is 65%, 0.65. And a sample of 15 children is chosen. Okay. Find the probability that more than 12 owns a bicycle. Now, this is a simple question, right? Second part, we will apply normal approximation. So now if you see, you always have to explain the what perimeters. We know that the binomial perimeters are NP, means total number chosen, and out of those the probability of success. Whatever you're talking about, what you're talking about here, you're talking about children who owns a bicycle. So what is the probability? 0.65. So probability of success is 0.65. And this is the formula which will be given to you in the MF19. So you know, you don't need to learn it by heart, but still. And this formula we will apply, and Q we know is 1 minus P because P plus Q equals to 1. So let's see here. So we always define the variable, random variable X, which is the number of children who owns a bicycle. And then I'm writing the perimeter, which is 15 and 0.65. So X is a binomial such that N is 15, P is 0.65. And I have to find the probability that more than 12 children owns a bicycle, right? So more than 12 mean 13, 14 and 15. So I will find out the probability of 13, 14, 15 and add it up. And this is my formula. So I'm simply plugging in the values in it. You can notice my P is 0.65 and my Q is 0.35. So I'm substituting the values here and then I am calculating it. So you can calculate it on your own here. And I got the answer 0.0617. So this is how we will do part 1, which is usually very simple for students. Part 2 is at times become challenging. So now if random sample of 250 children is chosen, right? Now you have selected 250 students. And you want to find the probability that less than 179 owns a bicycle. If we will start doing it by this method, it will take a long time and very tedious job. So that's why question is also suggesting use a suitable approximation. In S1, because of the limited syllabus, you know the only suitable approximation you have studied is normal approximation. So it's not difficulty here to identify. Whereas when you will have S2, if you take it, then there are more approximation and then you have to find out which one. You check the conditions. So anyway, coming back to this. So what are the conditions? Conditions are when we are applying normal approximation to the binomial distribution, the condition is that NP should be greater than 5 and NQ should be greater than 5. So in this question, N is 250 and your P is 0.65, right? Probability of success that a child owns a bicycle. And you have to find the probability that less than 179 owns a bicycle. Actually, before we begin, I would like to tell you one thing here, that 179 is a discrete data, right? Binomial distribution is for discrete data and normal distribution is for continuous data. So we need to change this value of X into continuous data now, right? So I want to build a concept of continuity correction here. When question is saying probability of X less than 179, you have to add 0.5 or subtract 0.5. You have to decide it, right? To change this discrete data into continuous data. So how you will decide? I'll tell you the formula also here, but let's develop a concept here. When I say x less than 179, so look at this red line. I mean all these values which are on this side. If I add 0.5, it will be 179.5, and then it means all the values left hand side from here. Now if I go from here, 179 will be included in it because line is going all the way from here. So 179 will be part of it. Whereas if I subtract 0.5 from 179, it will be 178.5. And if I go on the left hand side, why left hand side? Because question is saying x is less than. So it will not include 179 in it because 179 is not on this side. So because there is no equals to symbol, I will go from here, because if I go from here, 179 will be part of my calculation. So that's why we are subtracting here, right? We are subtracting here. So it will become what? It will be x less than 178. Let me write here rather than talking orally. So it will be probability of x less than 178.5. So this is how I have decided this, found out, right? So basically you can do it on the paper number line if you cannot imagine it, or it's very easy. Now here I have written here few continuity correction. You see, if I say greater than 179, now you start thinking on the same line which I've explained. If I say greater than this, right? So because it is a discrete data, if I change it into continuity correction, either I have to add 0.5 or I have to subtract 0.5. If I add 0.5, it will be here and I will go all the way from here, right? And if I subtract, it will be 178 and then I will go from here. When question is saying x is greater than 179, it means this is not included. So you will go from here. That's why you add 0.5. So similarly, I have done the work here for you, and I would like you to draw a number line for each case and see you understood or not. If you cannot do it, then you can write in the comment and I'll explain it to you. But try to find out like this all the values, because you don't need to learn it by heart. Some children learn it. Okay, if it is less than, I will do minus. If it is greater than, I will do plus. If it is greater or equal, I will do this. There's no need to learn it by heart, right? Okay, so let's continue the correct question. So question was saying probability of, let me write here. Question was saying probability of x less than, less than 179. Let me write it here. So it was saying less than 179, and when we change it into after continuity correction, it became x is less than 178.5. Now, because we are using suitable approximation, so we have to check the condition, and condition was NP greater than 5 and NQ greater than 5. My N was 250, NP was 0.65. So I am doing N multiplied by P. Answer is more than 5. N multiplied by Q. You know what Q is? 1 minus P. So it is 0.35. So both answers are greater than 5. So this condition is met. So I can say yes, condition met. So I can apply normal approximation, right? Now my distribution will be normal and it will be NP dot NPQ. So this is my mu and this is my variance. You have to write all this in the paper also, right? So after that, you will use this Z form, because now you have to change X data into Z so that you can read the table. So now in place of X, when I will write Z, I will apply this formula. You know, X minus mu divided by the standard deviation, which is my root NPQ in this case. So I'm simply picking up values from here of mu and standard deviation and put it in this formula here. So I got Z less than 2.1215. And I have taught you how to read the table. So you will read the table and you will calculate the probability. I hope you understood. Let me just explain. I explained here also the method in case if somebody has or somebody needs more explanation here. So when I'm calculating z is less than 2.122, what did I do? 2.1 is the first decimal place. So I checked from here, all the way went here. 2 is my second decimal place. So this is I got from here. And then third decimal place was this 2. The number written underneath was 1. So I did 0.9830 plus 1 at the end, okay, with last digit. So this is how I got my probability. So thank you very much for watching this video. If you have learned something, press like button, subscribe it, and share it with your friends. Other people may also get benefit out of it. Your constructive feedback will be very encouraging for me and help me to make better videos. Take care. We'll see you in the next video. Bye bye. Allah Hafiz.